Okay?
Yes.
Okay. In this lesson, I'm going to teach you how to use this redox table. This redox table, it is a reduction because can you see the electrons on the left hand side? It's a reduction reaction. You also notice that there is a double arrow. So if you want oxidation reaction, we start from the right and move to the left. And here in this table, all the substances on the left are oxidizing agent and all the substances on the right are reducing agent. And the strength of reducing agent increases from bottom to top. That means lithium is the strongest reducing agent and F minus is the weakest reducing agent. Let's go to the left hand side. The strength of oxidizing agent increases when you go downwards. So fluorine is the strongest oxidizing agent and Li plus is the weakest oxidizing agent. So lithium has the ability to give electron is very high. But fluorine, its ability to accept electron is very high. It is ready to get oxidized. And what about lithium? Lithium is always ready to give electrons. It is ready to undergo oxidation, while F2 plus is ready to undergo reduction. So now I'm going to teach you how to take down an equation and do this kind of calculations to find out cell potential. Let us say I am making a cell with silver and chromium. And in the chromium, the electrolyte is chromium 3 plus. It's given in the question. So now how are we going to take down the equation from this redox table and how to write the equation, and I'm also going to teach you how to calculate EMF and how to write cell notation. We are going to see three of them. Now silver and chromium 3 plus. First go to the redox table, identify the silver equation. The silver equation is here and the chromium 3 plus, that means chromium to chromium 3 plus. There will be an electrode like this. You have chromium here and you have got chromium 3 plus in the solution. They don't have to write even the negative ions. If they write a positive ion, it's fine. Then you have silver and you have got Ag plus in this cell, Ag plus. Now, since they have written chromium 3 plus, as I told you, there are something like iron, copper, chromium, all these things, they have got many ions. So look for an equation where chromium becomes chromium 3 plus. I can see this one is on the top. So it's very clear. Chromium is on the top and silver is at the bottom. So chromium is the anode and silver is the cathode. So when you are writing equation for anode, we have to use chromium. When you are writing equation for cathode, we must use silver. But when you write equation for anode, we must always swap the equation. Let's write anode equation. We go to chromium is our anode and we start from the right hand side. We start with chromium and you put a single arrow. If you use a double arrow, 1 mark will be taken away. So chromium, and what is it going to give you? Chromium 3 plus 3 electron. Do you realize the electron is on the right hand side? So it's an oxidation reaction. Let's go to cathode. Cathode we have got Ag. Here we do not change the equation. We just change the double arrow into single arrow. So gives Ag. Now we have got these two. How many electrons are here? 3. How many electrons are here? 1. So we have to multiply this equation by 3. So what do you get? 3 Ag plus 3 electron gives you 3 Ag. Let's also write down the equation for anode here. Cr gives Cr3 plus 3 electrons. Cancel the electrons when you are adding. So you are going to have on the left 3 Ag plus Cr gives 3 Ag plus Cr3 plus. You must understand this equation. As the reaction proceeds, the concentration of Ag plus decreases, mass of chromium decreases, but the mass of silver increases and the chromium 3 plus ion concentration decreases. Ions are in the solution, so they have concentration, and solids have got mass. So you can say if the mass decreases, sometimes they use the word eroded, as I showed you in the previous video. And here the mass increases. How to calculate EMF of this cell? To calculate EMF of this cell, you must know that the cathode is the one that's going to come first in the equation. We write E naught cell, it's not E naught, it has a dash there. E naught cathode minus, that tells you it's a standard conditions. E naught anode. The cathode here is silver. Silver is here. What is the value? Plus 0,80. The anode here is that particular chromium. Chromium gives chromium 3 plus, which is minus 0,74. Minus 0,74. You add them together, you get 1,54. It has a unit, so you have to write the V also. That is the EMF of the cell. How do we write cell notation? What is the rule for writing cell notation? Anode must be on the left, cathode must be on the right. The rule is reducing agent first. Then what does it change into? Oxidized species. Oxidized species. Then you draw a double arrow. Then what do you have? Oxidizing agent and reduced species. That is what we are writing. But sometimes you may not have electrodes that are reacting. Sometimes you have inert electrodes. In that case, we put the inert electrode here and the inert electrode there. So this is how we write. Now shall we write down the cell notation for this cell? Let's look at the reaction. This one is the reducing agent. So chromium is on the left and it becomes Cr3+. We can write it is a solid. This one is aqueous. And the double line tells you it's a salt bridge. It's a simple way of writing the cell. We don't have to draw a diagram. It's another way of writing the cell. Then the oxidizing agent is chromium 3+. Then you write chromium. Then what does it become? It is, that's all. There is nothing else here. It stops there. Okay, this is how we write the cell notation. But sometimes you may have chemicals like chlorine. Now, if you have got chlorine and magnesium, they are making a cell. So what is going to happen? Chlorine, when you look at the table, chlorine is at the bottom and the magnesium is at the top. So this one is the reducing agent and that one is an oxidizing agent. If you write cell notation for this, you write magnesium Mg2+. Then you draw a double line. Chlorine is a gas. Gases cannot operate on its own. They need an inert electrode. The electrodes that are used as inert electrodes are either platinum or graphite. So let's use the platinum. Then what happens here? The Cl2 gas and Cl minus. You don't have to write down if it is 2Cl minus. You don't have to write the number of moles. You just write the symbol of the ion that is present. This is how the cell notation is written for the gases. If the gas is on the left, platinum will come to this sign. Okay, so the inert electrodes are written on both sides. If it is anode, on the left first, and if it is on the cathode, it's on the right hand side. That is how it is written. Thank you.